Right now, Earth sits in exactly the right place. Not too close to the sun, not too far. A narrow band of space scientists call the habitable zone, where water stays liquid, oceans don't boil away or freeze solid, and life has had roughly 4 billion years to figure itself out. Every single other orbit in this solar system is, by comparison, a death sentence. Get too close to the sun, and the heat alone ends everything within days. Get too far, and the cold does exactly the same job, just slower and quieter.
It's easy to take our position for granted because we've never had to imagine the alternative. So here's the experiment. What if we could pick Earth up exactly as it is right now? Same atmosphere, same oceans, same 8 billion people going about their ordinary lives, and drop it onto a completely different orbit. Not once, 8 times. Every planet in the solar system, one after another, in a random order, with no warning before each jump, and absolutely no way back to where it started. Some of these jumps will feel almost survivable in the first few minutes. A couple will lie to you before they kill you, looking almost normal right up until the moment everything falls apart. Others are instantly, obviously fatal the second Earth arrives. And we're deliberately not going in order, not closest to farthest, not smallest change to largest. We're jumping wherever the numbers take us next, because in space, there's no such thing as a gentle transition between one orbit and another. One moment you're home, the next, you're somewhere the laws of physics never built you to survive.
Each position gets a verdict, a survival percentage, and a countdown to total collapse. By the end, we'll have a full ranking, from the fastest death of all 8 to the one position that gives Earth something close to a fighting chance. Let's find out exactly how much luck it actually takes to be alive in this solar system. 8 jumps, 8 verdicts, no way home until the very end.
Jump 1. Mercury's orbit. Just 0.39 astronomical units from the Sun. Less than half the distance Earth is used to, and close enough that the real Mercury's day side regularly reaches around 430 degrees Celsius. Drop Earth onto this orbit, and the oceans don't gradually warm up. They start boiling within the first few hours. Forests across the daylight hemisphere ignite without a single spark, purely from radiant heat crossing the ignition threshold of dry wood. Within a day, every major body of surface water on the planet has either evaporated or is well on its way there. And it doesn't stop with the water. Earth's rotation, no longer able to fight against the tidal pull of a star this close, begins slowing down, dragged toward the same fate the real Mercury already suffers. One side permanently scorched, one side permanently frozen. There's no recovery scenario here, no adaptation window. Survival chance, 0%. Time to total collapse of the biosphere, roughly 48 hours from arrival.
Jump 2. Saturn's orbit. 9.5 astronomical units out from the Sun. At this distance, Earth receives somewhere around 1/90th of the sunlight it's used to. Oceans freeze solid within days, not years. Saturn's massive ring system now stretches visibly across half the sky, a strange and almost beautiful sight for however long anyone is left to look up and see it. The real threat, though, isn't the cold. It's the radiation. Saturn's magnetosphere generates radiation belts powerful enough to overwhelm Earth's own magnetic field almost completely, flooding the surface with levels of radiation our biology was never built to filter out. Auroras blaze permanently at both poles, not as a beautiful phenomenon anymore, but as a visible warning sign of exactly how much radiation is getting through.
Between the extreme cold locking down the oceans and the radiation breaking down everything living on the surface, there's barely a 1% chance anyone makes it past the first few weeks.
Jump 3. Venus's orbit. And here's the twist nobody expects. At 0.72 astronomical units, the raw temperature from sunlight alone is actually survivable, close to a warm summer day back home. For the first several hours, it genuinely feels like nothing catastrophic happened at all. People start to relax. That's exactly the problem. Distance was never the real danger on this orbit. It's what that distance slowly triggers. A runaway greenhouse effect, thickening Earth's atmosphere day after day, trapping more and more heat than the planet can release back into space. The clouds grow denser. The rain turns acidic. Within a matter of months, without a single dramatic moment of impact, Earth doesn't just get uncomfortably hot. It slowly transforms into a second Venus.
Jump 4. Pluto's orbit. 39.5 astronomical units from a sun that's now nothing more than an unusually bright star lost among countless others in the sky. Surface temperature at this distance, roughly minus 230 degrees Celsius. The atmosphere doesn't just get cold here, it stops behaving like a gas entirely, falling out of the sky as solid frost and snowing itself directly onto the ground. Oceans freeze to their absolute depths within hours of arrival, not just at the surface, but all the way down. There's no gradual decline to observe, no slow adaptation period for anyone to react to. Just silence, spreading darkness, and ice closing in almost instantly from every direction at once. Of all 8 jumps, this is one of the fastest and quietest deaths in the entire experiment.
Jump 5. Mars's orbit. 1.52 astronomical units out. Noticeably cooler, but not instantly deadly the way most of the other jumps have been. At the equator, right around noon, temperatures can still climb close to 20 degrees Celsius. For a brief moment, this genuinely looks like the one position Earth might actually survive. But solar energy across the whole planet is still down roughly 50% compared to normal, and that alone is enough to slowly strangle agriculture on a global scale. Harvests fail one season after another. Ice caps expand a little further every single year, eating into land that used to be farmland. It isn't a fast, dramatic death like most of the other orbits. It's a slow, grinding extinction that plays out over roughly 2 to 3 years as the planet quietly runs out of food to feed 8 billion people.
Jump 6. Neptune's orbit. 30.1 astronomical units out. So far that the sun is barely distinguishable from the background stars around it. Equilibrium temperature at this distance, somewhere around minus 200 degrees Celsius. There's no drawn-out struggle to witness here. Oceans freeze to their deepest points within minutes of arrival. And whatever atmosphere hasn't already collapsed onto the surface as frost finishes doing so almost immediately after. Of all 8 positions in this experiment, Neptune's orbit produces one of the fastest, quietest deaths of the entire planet. There's no warning phase, no slow decline anyone could react to or prepare for. Just an almost instant transition from a living world to a frozen, silent one.
Jump 7. Jupiter's orbit. 5.2 astronomical units out. Cold on its own, but temperature was never the real danger waiting on this particular jump. It's the neighbor. Jupiter's radiation belts are thousands of times more intense than anything Earth's magnetic field was ever built to filter, and auroras flare uncontrollably at both poles almost from the moment of arrival.
Then the ground itself starts shaking. Jupiter's immense gravity begins actively distorting Earth's own orbital path, triggering earthquakes and tidal chaos on a scale never recorded in human history. Coastal regions are hit by waves pulled directly by a planet 300 times more massive than Earth itself. Within just a few weeks, Earth's orbit destabilizes entirely, sending it drifting outward onto an unpredictable new trajectory with no clear final destination. This isn't a single catastrophe playing out. It's three of them happening simultaneously. Radiation, seismic chaos, and orbital collapse, all stacked on top of each other from the very first hour.
Jump 8. Uranus's orbit. 19.2 astronomical units out. And here's the strangest twist of the entire experiment. The real Uranus rotates almost completely on its side, tilted 98 degrees relative to its orbit. Placed onto this orbit, Earth inherits that exact same sideways spin. One pole locks into roughly 40 years of continuous, unbroken darkness, while the opposite pole endures 40 years of uninterrupted daylight. Equilibrium temperature at this distance, around minus 205 degrees Celsius. It isn't the single strangest death of the 8 jumps, and it certainly isn't the fastest, but decades of uninterrupted darkness on one hemisphere are more than enough to collapse the entire biosphere long before the extreme cold even finishes the job on its own.
8 jumps, 8 verdicts, and through every single one of them, there was exactly one position in this entire solar system where Earth actually belonged. The one it's sitting on right now, at this exact moment as you watch this. Not too close, not too far. A window so narrow that shifting Earth's distance from the sun by even a few % in either direction would have ended everything we know within years, not centuries. That's not luck repeating itself by accident. That's the one orbit out of 8 where the math actually works in our favor. If you enjoyed running through this experiment, subscribe, because next time, we're not moving Earth anymore. We're finding out what happens if it collides with something it was never supposed to meet.